Okay. Um, if you can hear my voice a little better, it's because I went out and bought a high-tech little microphone. So hopefully it works better. So we're in section 5.8, and it's solving higher degree polynomial equations for their roots. Big old fancy title, but remember a root is where a graph crosses the x-axis. So they decided to put this in the parabola section because in parabolas we started talking about roots. So, even though this is not a parabola, it still has roots. Thus, they threw it in section 5. All right. Whoops, sorry for all that. So we have a cube here, and if you remember, anything that's raised to an odd power is its ends are going to be down and then up. So a fifth doesn't matter, it's going to be down, something's going to happen in the middle, and then it's going to be up. Whereas anything raised to an even power is going to be up and up. And then if we throw negatives in front of them, it's going to turn. All right. Where do we lay off? Sorry, dog was once again barking at the snow. All right, so if we look at this, and I have over here a picture of what this graph looks like. There it is. So of course, if we wanted to know what are the roots of this is an easy one. We can look at the graph, and we can see that it crosses at 1, 2, 3 times it crosses the x-axis, and that's because it's raised to the third power. So the roots are -3, +2, and +3. Now this was an easy one because we could graph it and we could get the answers right away. Another way was to have factored this. And you may be looking at me saying, well, we don't know how to factor something to the third power. You're absolutely right, you don't. But let's do this. X cubed. Well, the only way I'm going to get x cubed is an x squared times an x. Okay, 18. How am I going to get 18? Well, I could get 9 and 2, so let's do 9 and 2. And it's got to be a positive 18. So I could make this, and there's some negatives in here, so this has got to be a negative and a negative. If I FOIL that out, I still see that I get this above. And if I see this x squared minus 9, I get x minus 3, x plus 3, because I see that's a difference of 2 perfect squares, and x minus 2. And if I solved each one of these, 3, -3, and 2. All right, so those are my roots. And notice, if I put each one of these x's back into this problem, let's put a 3 back in here. 3 cubed minus 2 times 3 squared minus 9 times 3 plus 18. So that's 27 minus 18 minus 27 plus 18. Well, a -18 and a +18 cancel out. A 27 and a -27 cancel out. I get a 0. And that makes sense because f of x is fancy for y. And this point right here is -3 for x and y is 0. And this point right here is 2 and a y is 0. And this point right here is a 3 and the y is 0. And that's going to be important later on. Okay, let's go to the next one. Find the roots of this equation. I am going to encourage you, highly encourage you, that you take out your calculator and graph this. And when you graph it, you get this picture right here. First off, let's do a little knowledge. This is to the 4th power. And we know anything that's raised to an even power as its highest degree, both of its ends are going to be up or both down. And we can see that right here. This is both up. But if we take our definition from the other page, roots are where the graph crosses the x-axis, and we look at this picture right here, this graph is not crossing the x-axis, so that means the roots are imaginary. Wow, what's wrong with this computer? So, I'm going to take this, and I'm going to factor it. I got x to the fourth plus 5x squared plus 4 equals 0, because when I set it equal to 0 is when I want to find the roots. All right, so this is going to be factored. Okay, x to the fourth. I'm going to try x squared and x squared. How am I going to get a 4? Two things that multiply to a 4 but add up to a 5. Well, that's easy. That's 4 and 1. And it's going to be plus. Now, if I set each side equal to 0, and I solve, I already see my answers of imaginary appearing. What squared gets me a negative 1? Well, if I just take the square root, x is plus or minus, well, what's the square root of negative 1? I. And if I take the square root over here, x is plus or minus, the square root of negative 4 is 2i. And there are my 4 answers. My 4 imaginary roots are I, negative I, 2i, and negative 2i. See, it's raised to the 4th power, so therefore there have to be 4 roots. And in this case, all 4 roots are imaginary. And there are my 4 roots. Okay, find the roots. Once again, this is to the 5th power. So I know it's an odd power, so it's going to be 1 down, something going on, 1 up. Take out your calculator, graph it, and this is what it looks like. Now, you're also saying, well, Mrs. Trulin, you told me that since it's to the 5th power, there have to be 5 roots. And when you look at this picture, there are 1, 2, 3 roots. And it looks to be my roots are 2, 0, and negative 1. All right, so I'm going to do the math behind it to make sure that I do indeed come up with those 3 answers. Because on the Regents, you're going to have to show work as to how you got your answers. So I'm going to come back to this problem right here, and I'm going to start my factoring. The first type of factoring is always greatest common factor. So I'm going to pull out an x cubed. And look what I'm left with. And set it equal to 0 because you're finding roots. I'm left with a nice quadratic that I can factor rather easily. Let's see, that's going to be a minus 2, and that's going to be a plus 1. And x cubed, I'm going to show you something new here. X cubed, if I factored it, is really x. So now do you see what I have? I have 5 roots. 1, 2, 3, 4, 5. Because I'm going to take each one of those, and I'm going to set them equal to 0. 1, 2, 3, 4, 5. This is called, we've already learned this, this is called a multiple. It's a multiple root. It's actually the same root that shows up 3 times. So there indeed are my 3 roots, 0, 2, and negative 1. Now, this one is asking us, is 1/2 a root? And this is simply a yes or no question. So once again, take the calculator out, graph this on your calculator, and does it cross the x-axis at 1/2? Well, it certainly looks like it does. But once again, I'm going to have to do some kind of math to prove it on the regions. So don't make this hard. If you remembered from the beginning, if I stuck 1/2 in here, it better equal 0. Because remember, if we went back to that first page, every time we looked at a root, the y value ended up being 0. So, let's figure it out. 1/2 cubed is 1/8. 1/2 squared is 1/4 minus 1. 2 times 1/8 is 1/4. 3 times 1/4 is 3/4. Well, 1/4 plus 3/4 is 1, minus 1 is 0. So yes, indeed, when I figured this out, I bring down all my math, this is a root. So yes. Now, if this was a multiple choice question on the regions, all you'd have to do is look on your graphing calculator. If it was a free response, you would have had to show all this work. And the last one. Now, this is why you have to know how to show work, because this is an imaginary root. And if you graph it, well, we don't know how to graph imaginaries yet. It's very simple. We will learn. But is 3i radical 2 a root? Imaginaries means it doesn't cross the x-axis. So let's stick that 3i into the problem. And that better all equal 0 when we figure it out. Well, right here I like this. This 2 and this 2 cancel out, so I know that's 3i. All right, 3i over 2 squared is 9i squared over 4. I'm going to stick with that for a second. Well, I squared is -1, so this is 5 times -9/4. So that's going to be -45 over 4. And let's bring down the rest of my problem. All right. Let's do this over here. 3i over 2 cubed would be 27i cubed over 8. I cubed is really -i, so that's -5 times -27i over 8. If I multiply 5 times 27, that's 135i over 8. Now, does this all equal 0? Well, you could get your calculator here and do it, but a little common sense will show that this does not equal 0, because everything would have to cancel out. Remember back here where it just came out to a nice cancellation of 1 minus 1 got me 0? Well, and actually, where was it? It was this one right here where the 27 and the 27 canceled out, and then the 18 and the -18 canceled out. Well, look here. +3 would have to cancel with a -3. This is not -3. -45 divided by 4 is not -3. It's negative something, but it's certainly not -3. So this is not a root because we didn't get 0 here. And then this would have to cancel down to -3i to cancel out with this +3i. So no, 3i over 2 is not a root. Okay, That's it for today. Done.